We're going to go live here. Hello, hello. Okay, sorry. Got that going. We got this going. And then we have that. We have this. Hello, hello. Welcome, welcome, welcome. And group experience. And then group. And then share. Okay, good. What? Are we doing it? Okay. So, welcome. What we're going to do is we are going to read the abacus. If you want to learn how to do math on this abacus, I will teach you. If you are willing to learn something different, learn something new, learn something that might be a little that might be a little bit easy. This is easy, simple to use, easy to understand. So what we're going to do is we're going to read the abacus. When we read the abacus, we'll be moving our beads. So the first thing we're going to do is move our one bead. Notice I'm moving one and then I have two. So just as I write 1 and 2, then this is 3, and then we have 4. Welcome everybody. Thank you for joining. My name is Lynette. I am an abacus teacher and I'm here to teach you how to use an abacus. We are going to use an abacus. We're going to use an abacus. That's what we're going to do. We're going to use the abacus. Welcome, welcome, welcome. Let me know if anybody have any questions. Any questions? So what we're going to do is read the abacus. This is 5. That is the value of 5. The top bead will always be a value of 5. That's what, whoa, that's not what it is. There, here it is, 5. So when I restart, I have 5 as the top bead. And then I have 6. So how do I know? 5 on top, 1 on the bottom. Together, they make 6. And then we have 7, we have 8, we have 9. And that's what we have here, 9. Sometimes it's easier to see what the numbers is, but this is what it looks like. That's what 9 looks like. So when we look, this is 8. How do I know? We have 5 on top, 6, 7, 8. Let me know if you have any questions. We have 7, right? 5, 6, 7. We have 6, 5, 6. And then we have 5. The top bead will always be 5. Now, when we look, every bottom bead is a value of 1. So this is 4. When I take away 1, now I have 3, and I'm just counting backwards. 2, 1, and then we have 0. Let me know if you have any questions. Any questions at all, let me know. Oh, that's interesting. Oh, that's interesting. Okay. How are we doing? Any questions? So what are we going to do? Thank you so much for the likes. Thank you so much for the likes. What we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we'll be doing adding, subtracting, multiplication, and division. I don't know if we're going to get to division, but the first thing we're going to do is learn how to read the abacus, because if you don't know how to read the abacus, then we don't know what we're doing. So again, what are we going to do? We're going to read. This is 0. So because this is 0 and then I have 1, this is the 1 bead. When this is 1, and then we have 2. When we look at it, this is 3. Thank you so much for the hearts. This is 3. This is 4. Okay, now we have 4. When we have 4, notice that the top beads is a value of, the bottom beads is a value of 1. So when we add it all together, this is 4, like they're holding hands, right? Because they're holding hands, these are the value of 4. So let's see. How are we doing? Anybody have any questions? So what is this? This is 9. How do I know this is 9? Because the top bead is 5. Then we have 6, 7, 8, 9. Together, this is 9. When we take away that, this is 5. And then we have 6, 7, 8, and then 9. Make sense? And then after 9 is we have 10. 10 looks very similar. 10 looks very similar to how we, to how we write. Wow, I have this flaky thingy. Okay, so when we look, and I have my values, my place values, every column is a place value. Hello, Tiffany. Thank you for the smile. So we have our ones, our tens, our hundreds, our thousands, our 10,000s. When we read it, this was 10. When we have 10, this is 11. Notice 11 is a 1 and a 1. We know how to write it, right? But sometimes it's nice to see what it looks like. So when I line it up, we have 1 and 1. So tens and tens and ones. Oh, good. Thank you, Tiffany. Thank you. I'm glad. I hope this makes sense to you. Let me know if you have any questions, because it's just you and me right now. You and me. So what we're going to do is we're going to do 12. When we do 12, if you notice, we have our ones and our tens. That's how we write 12. So on the abacus, we do the same thing, our 1 and our 2. Make sense? So this is 12. When we look, we have our hundreds, our thousands, our 10,000. So what do? Is we could do this. This is 512. We can do this one, which is 13, 513. And we're just slowly to understand how to count on the abacus. So this is 7,512. No, 13. Yeah, that makes sense. So when we continue, that would be 97,513. Yeah. So again, well, what about this? Well, this is where our decimal sits. Our decimal sits between the ones and the tenths. So the ones and the tenths, and then we have the hundreds. So the ones, the tenths, and the hundreds. So the decimal sits between here. The decimal means what? It doesn't sit on a place value. So we have our ones or our tens. Now, you might be wondering, well, why am I here? If you notice, let me give you a close up. If you're wondering, I have this here. How do you know how many decimal places you are? Oh, that's a very good question, Becca. You can actually choose. So if you want to, like a Pokemon, you could choose this place value or you could choose this one. So it all depends on what you think your answer will be. So if I choose this one as my place value, then I have all of these to be my decimals. Does that make sense, Becca? So when I look here, I have my ones and my tens, but then I don't have any hundreds because my abacus is short. This is a 7-column abacus, and so my abacus is a little short. So then I will have my tenths, hundredths, thousandths, millionths, and then what? 10 millionths. Yeah. Yeah. So that's why I usually start over here. So then I would move everything over. And it's just the same thing how we write. So we have our ones, tens, hundreds, thousands, and 10,000s. That was a very good question. Thank you so much for asking. Let me know if you have any more questions. Let me know if you have any more questions because I would like to, continue on with this conversation. I'm happy that this all makes sense. And what we're going to do is what we're understanding is we're reading the abacus. So let's go back. Let's do a review. Let's do a review for those people that just joined. So the first thing we're going to do is understand that this is 0. Abacus starts with the 0. So with this is 0, this is 1, 2, 3, 4, right? How would you do 3 plus 6? Ooh, Anthony, that's a very good question. That's a very good question because we have 4 and then we have 5. When we have 5, we'll do 6. So notice that we have 6. One beat on top and one beat on bottom, right? So now the question starts. Oh, maybe I should write it out. So the question starts. Let's see if I can find it. Three. Okay, so there we go. We have our question. 3. Here is 3. When we have our question, we have 3, right? And then do we have 6? Oh, that's not 6. Here. There we go. 6. So the question is do we have enough beads to add the 6? Yes, we can. So we have a 5 and a 6 and we bring it together. And my final answer is 9. Does that make sense, Anthony? So when we look at it, we want to make sure we have enough beads. If we have enough beads, then we want to be able to do it. Make sense? Now notice when I take it away, I'm moving it away from the horizontal bar. When I'm adding, I go to the horizontal bar. But thank you. That was a very good question. Sometimes I get stuck on how to read the abacus, but if you're ready for it, then we can do it. Thank you. Let me know, Tiffany, if you have any questions, and I will do my best to answer as long as they're abacus questions. Right? Thank you for the follow, Anthony. So when we look, right, now what we're doing now is that we understand how to read the abacus. Let's go on. Let's move on, Lynette. Okay, what we're going to do is we're going to start learning how to move the beads. Now, if you notice, the beads they have edges. So we want to do is we want to be happy. We want to be happy when we do math, right? We want to be happy because we're going to be gentle. We're going to be gentle. We don't want to be aggressive. So notice that, oh, I got to move it down there. Well, notice that when I move my beads, I'm using the edge of I didn't think I'd be learning abacus today. That's funny. That's so funny. Yes. So notice that when I move the beads, we're going to be happy when we do math. And when we're happy, we want to be gentle. We're not going to be aggressive. We're going to be gentle. We're not going to be angry when we do abacus. Why? Because the beads itself is very gentle. It's not delicate. These are made out of plastic. It's not delicate. What it is it's gentle. So notice it's very easy to move the beads, and I'm at the edge of the bead to move the beads. So no matter how big your big burly hands are, you should be able to move the beads with not a problem. This is a standard size abacus. Okay, this is a standard size abacus. It doesn't matter how big burly hands you are. You have to make sure that you're very gentle. It's a gentle touch. It's a gentle touch, right? Makes sense? So can we do small adding? Yes, we will do small adding. The first thing I want to do though is understand to how to move the beads, because there's been some questions, there's been some complaints, not to me, but I've been noticing that there's some complaints that it's very easy to move the abacus. And you're right, it's very easy to move the abacus. So what's going to happen is, even if you bump it a little bit, you're going to get a wrong answer. And then that's the other thing, is if you flick too hard, you'll notice that all the beads will move. So the first thing we're going to do is exactly what Tiffany has requested. Yes, we are going to do some small, simple adding. Now, in the abacus world, what we're going to do is we're going to understand about the add-in. This is the add-in. The add-in is the thing that we're adding to. We're not going to focus on the result. We're going to focus on the add-in. Why? Because it's all about the journey. It's all about the process. We want to marry the process and divorce the result. What does that mean? We want to know, how do we get here, right? We don't want to know how to get here. We're going to get there. We'll get there when we get there, right? But the thing is we need to make sure that we understand how to add the number. So this specific one is, how do we add the one? And again, I showed you a little bit how what we're doing is, when we have five, this is the number five, the dot P is five. Then what I'm going to do is I'm going to add the one. When I add the one, I'm going to add one bead, right? So there was another question, it's like, why don't I just label it all? It's like, you could, but the problem is it can be any one bead, right? So this is one. If I have six and I want to add one, I'm going to add one. I don't want to be labeling it saying that this is one, because when I have eight, right? 5, 6, 7, 8, and I want to add the one, I can't be adding this one. I got to go all the way down here and add the one. So then I know my answer is 9. Does that make sense? So when we're doing this, we just want to move the one bead. Now, after 1 is 2. We already know that, but I want to just show you what it looks like to be adding, right? So I have 2. I have 6 on the abacus. I have 6. Again, I'm going to look at this number. I'm going to add the 2. When I add the 2, I'm moving these 2 beads. Yeah, easy, simple. So the question is do I have enough? Yes, I do. I have enough. So I'm going to add my 2. And then it goes again to 4. Let's do 4. So 4 doesn't have a lot of questions. 4 is just either 5 plus 4. Do we have enough? Yes, we have enough beads. So we're going to add the beads. And then my final answer is 9. And then when you see it, when we add it, we can also subtract. Subtracting just means we're going to remove it away from the horizontal bar. So when we add, we know how to subtract. It's the opposite, right? It's the opposite movement. If we go up, we go down. If we go left, we go right. If we go together, we go apart, right? So when we add, like here, when we minus the 4, minus the 1, I'm going to take away the 1 like this. How would you do in the case of 6 plus 4? Ooh, that's a good question. But we're not there yet, because as long as we know that we have enough questions, enough beads, that is actually a new thing. Not a new thing, that's another thing. So what we're going to do first is we're going to understand, how do we make a 5? Let's do that. Is that all right? So before I continue on, because that's the next phase of understanding how to do the abacus. If that's okay, can I put that on a little bit of a hold? Can we put a pin in that? Oh, I should do that. Can I put a pin in that? Yes, please. I'd like to put a pin in that. And so the first thing we're going to do is understand that we're going to move the beads, right? So we're going to take away, we have 3 and we're going to take away the 1. I've never imagined myself learning the math. Yeah, right? So now we have 2. So we understand how to read, right? We understand how to read. We understand how to move the beads. Now, again, when we did the 5, we do the same thing. We need to understand the add-in. So when we add, right, we have 2 and we add the 5. All we're doing is we're adding the bead to 5, right? So same thing with 6. 6 is, I have 1 and I have 6. When I add 6, I'm moving these 2 beads to add the 6 together at the same time. And so what we're doing is, I love math. I've never heard of this before. Oh, that's very interesting. That's very interesting. And I'm so happy you're here. I'm very happy you're here. So then we want to add the 2. I have 7 and I want to add the 2. So notice it's very visual. It's very tactile. right? Because it's visual and very tactile, it's easy to see. But it goes back to really understanding how to read the beads. So we know, what number do we think this number is? What number is on my abacus right now? This one right here. Just to keep track. I just want to keep track, and I just want to keep a pulse on making sure that we are keeping active when we learn. I'm looking for my thing. Yes, thank you. Thank you. It is 9. It is exactly. Thank you, KK. Yes, it is 9. So let me do a little review. We're going to talk about our ones, our tens, our hundreds, our thousands, our 10,000. So every place value in here is, every column is a place value. So when we look at 9, right, we could do 9. These are all nines. And it's on the decimal system, just like how we write, right? Just so, hello, Lando, welcome back. Welcome back, Lando. So remember, okay, what we're going to do is we're going to remember and understand that these are place values. So when I do this is 90, right? How do I know it's 90? Because it's my ones and my tens. Make sense? Okay. So the next thing we're going to do is we're going to go one step further, one step forward to almost answering Diamond's question. So the first thing we're going to do, okay, so we know how to add, we know how to subtract. So if I want to subtract the 7, again, what we're going to do is realize that when I take away the 7, we're moving it away from the horizontal bar like that. So this is adding 9, and then this is minusing 7. So my final answer is 2. Make sense? All right. So we are done with this. Oh, I don't know if, oh yeah, Ethan's not here. All right. So yes, Diamond had mentioned, what happens if you don't have enough? Well, what's going to happen is we're teaching the children how to make a 5. Why are we going to make a 5? We're going to make a 5 because we're going to have no freeloading numbers. So what does this mean is we're going to be understanding this concept. This concept is 4 plus 1 is equal to 5. 4 plus 1 is equal to 5. Why? Why are we teaching how to make a 5? Well, it's fine. It's a good concept to learn. I'm the children. Good. You're going to learn something. So what's going to happen is 1 plus 4 is equal to 5. Well, what does that mean? Well, we're going to utilize this 5. There's no freeloading numbers, right? So we're going to understand that this is the 5. Now, why are we going to care? Okay. Here is the question. Tiffany, here's a question for you. When you were smaller, like probably yesterday, did they teach you how to four? They told you how to memorize, right? Told you how to memorize. We don't want to memorize. We don't want to memorize. We don't want to memorize 4 plus 4. We don't want to memorize 4 plus 4 is equal to 8. Because that's not. I don't know if you know what a one-hit wonder is, but it's called a one-hit wonder, meaning that's only good for one scenario. Whereas this 4, when we do it this way, this actually is going to be modified. We're going to modify. We are going to. So here is this thing, what we call the abacus formula. When we do the abacus formula, what does that mean? We're going to look at this number, right? We're going to look at this thing. This thing is 1 plus 4 is equal to 5. We're going to change it. We're going to modify it. Why? We're going to make this by itself. When we make it by itself, this is what we're going to do, is we're going to have 4 is equal to 5. Does that look balanced? No, that doesn't look balanced, right? So what we're going to do is we're going to balance it. How do we balance this equation? Please put it in the chat. How do we balance this equation? What do we do to balance this equation? What do we do? We should know how to minus, right? Subtract the 1. Thank you, KK. Yes, subtract the 1. So what we're going to do is we're going to minus the 1. What does that mean? What we're going to do is we're going to substitute. Hopefully this is okay. We're going to substitute this information into the 4. So when you look, why are we going to do that? Why? Why? Why are we going to do that? We're going to do it because, thank you, Ali. We need more lives this, you all. Okay. So what we're going to do is we're going to add the 4. When we add the 4, you will notice we don't have any more beads. So Diamond, it's very close to what you're asking, right? What if we don't have enough? If we don't have enough, what are we going to do? Now, instead of memorizing 4 plus 4, what we're going to do is we're going to understand this concept. I'm going to add the 5 and I'm going to take away the 1. So my final answer is 8. Okay, that's fine. That's fine. It's a little bit difficult. No. Why? Because now we can make it versatile. Let's do another question. Here is 3. When I have 3, I'm going to add a 4. I don't have enough beats to add the 4. What do? Right? So because I use the modification, I'm going to substitute my 5. I'm going to add the 5. I'm going to take away the 1. So my final answer is 7. Does that make sense? Is that all right? We can do it again. Why? Because now we're making the 4 versatile. So now instead of memorizing 4 plus 4, right? Oh, yeah, good. No, we're going to continue on because we got one more to go, right? So what's going to happen is we want to do 4 plus 4. We don't want to memorize 4 plus 4. We don't want to memorize 4 plus 4 minus 1. What's the strategy? Doubles minus 1. That's not even a specific thing. But here, we have 2. When I have 2, the question is I want to add the 4. Can I add the 4? No, I cannot add the 4. What do I do? What do I do? Put it in the chat. What do I do? I want to add the 4. So we're going to substitute this with this. Thank you guys so much for the likes. We're going to substitute this 4 with this 5. Why? Why? Because on the abacus, I have no more beads to add the 4. So what are we trying to do is we're trying to utilize our abacus, right? The whole reason of this live is to understand how to use the abacus. So yes, thank you, Allura. Yes. So we're going to add the 5 and we're going to take away the 1. So my final answer is 6. This is so easy. It is, but it's scalable. The first thing we need to do is understand the fundamentals. We're going to understand the basics. Once we understand the basics, then we can go into adding, subtracting, multiplication, division. And then what happens? Then it becomes, it doesn't matter how big the number is, you will know how to add a 4. You won't need to do all the other strategies that they have out there. Okay, so the first thing we understand is, so does that make sense? So my final answer is 6. Yeah? We can do it again. What? What do you mean do it again? We've already done it. This applied algebraic substitution. Yes, exactly, William. This is applied algebraic. Yes. And so what we're going to do is, and it follows very similar to algebra. So abacus is the gateway to complex math. We're going to do it again. We're going to solidify this concept. So what happens is we're going to solidify and compound our information. Notice I have a 4 and a 1. I can do it again with a 3 and a 2. Make sense? So what we're going to do, we're going to do it again. What do you mean? Because we don't need to memorize. We just understand this concept. When we understand the concept of how to utilize this 5, then it's easy to go all over the place, right? It's easy to add. We're learning simple numbers right now, but it does scale. But the first thing we need to do is understand the beginnings. Are we all right, Tiffany? How are you doing? You okay? So we're going to do this one. We're going to add the 4. When we add the 4, we're going to plus the 3. When we add the 3, there's not enough beads to add the 3. What? What are we going to do? What are we going to do? I don't know if Tiffany's still here. We're going to... So we're going to have the 3 and we're going to have the 5. Again, this is not it. Yes, thank you, Diamond. Yes, we're going to minus the 2. So when we have the 4 and we don't have enough beads to add the 3, we're going to plus the 5 and we're going to take away the 2. So my final answer is 7. Hey, Jane! Welcome back! Welcome back, welcome back, welcome back. So does that make sense? So what we're going to do, we can do the same thing. Again, we're not going to memorize our doubles. We know that when we add the 3, we want to add another 3. We don't have enough beads to add the 3. What do? We substitute. Plus the 5 minus the 2, my answer is 6. Bam! That's it. We're done. No, we're not done. We have more. But wait, there's more. Thank you so much for the likes. Anybody have any questions? How are we doing? Again, okay, you know what? Here's another one. So we have adding. We finished how to add. Now what do? We can subtract. What? Yeah. But look, they're very similar, aren't they? This is the concept. Now we're compounding our information. If we know how to add, we will know how to subtract. So if I have 7 minus 3, this is what we're going to do. We're going to minus the 3. To minus the 3, we're going to substitute. We're going to isolate the variable. We're going to make it by itself. So it's minus the 3 is equal to minus the 5 plus the 2. What? Why are we going to do that? Again, if we look, I'll have 7. When I have 7, I want to take away the 3. I don't have enough to take away the 3. Hey, hearts, welcome back. So what we're going to do is we're going to minus the 3. Notice this is now directions. I've been given directions on how to take away the 3. I don't need to think. I don't need to. It's very obvious what I need to do. All I need to do is minus the 5 and add the 2. And my final answer is 4. How are we doing? Any questions? Does that make sense? What's going on? Yeah? Okay. So, yeah. Okay. So we can do it again. If we had 6, right? Minus 3. These are all simple questions. They are very simple, but they get better. Easy peasy lemon squeezy. Yes, thank you, Shane. Thank you, thank you, thank you. So we have 6 and we add the 6, and I want to take away the 3. When I take away the 3, there's not enough beads to take away the 3. So what are we going to do? We're minus the 3. All we have to do is follow these directions like a mapicus. I don't know if that's going to work. Map. Like a map, right? A map tells you the directions. So we want to minus the 5, and then we're going to add the 2. And my final answer is 3. Okay, okay. So what happens? What happens? You know what? Let's take a bigger number. Let's take a bigger number and see what happens. Okay, let me find my bigger number because I'm tired of thinking. Let me find my bigger number. Is my bigger number here? Okay, so here's my bigger number. And you'll see the ease of this. So I have 1, 3, 5, 7, 8. Okay, what's my next number? I add the 2. Is there enough to add the 2? Yes, there is. I'm going to add the 2. Is there enough to add the 4? No, there's not enough to add the 4. What do I do? Well, remember when we add the 4, we're going to plus the 5 minus the 1. Can we do it? We're going to plus the 5 minus the 1. Then the question is we're going to add the 3. We're going to add the 3. Is there enough to add the 3? Yes, there is. I'm going to add the 3. And then here we have 1 and 1. 1 and 1. And that's it. So my final answer is 37,889. How did that work? How was that for you guys? Did that make sense? Thank you guys for joining. We have 11. I see the 11 people, but there's only 3 people talking. How's that going? Was that too much? Thank you for the hearts. Any questions? That's cool. Oh, great. Does that make sense? Maybe we're all listening. So far, so good. Okay, good. But wait, I got more. But wait, there's more. But is that okay? Did that make sense or did I lose anybody? So what did we just do? Notice that it is now scalable. So we had it where we understand how to move the beads and then we understand how to add the 5. When we add the 5, notice I didn't have to do big number. I didn't have to do big thinking. I just had to do little position agnostic. So that makes sense. Yeah. All right. All right. Cool. Cool. So we know how to add the 5. Do we want to do more adding of the 5 or are we ready for the next thing? Let me know. Does the adding of the 5 make sense? If not, I have more examples. More examples. How are we doing? Cuz I don't want to move forward if the class doesn't if I don't want to move forward if the class is still confused. Yeah? How are we doing? We're all right? Okay, then I'm going to move forward to adding the 10. What? What do you mean adding the 10? This is what we're going to be doing. We're going to be doing the carrying over, right? We carry over. What is it called? Like borrowing, carrying the 1, grouping, regrouping, trading? Is it trading? Thank you, Apple user. I'm not sure. Oh, you want to, okay, so what is 4? Okay, so 461 is what the answer is. Yes, fantastic. So when we look, we have 461. That's what the number looks like. 461. Thank you, Apple user. I don't know. So, what are we going to do? What are we going to do? What we're going to do now is we're going to understand how to make a 10. After we finish, okay, so and then after this, I'll tell you the big secret. But the next thing we're going to do is understand how to make a 10. Why are we going to learn how to make a 10? The 10 is what we do when we do carrying over, right? Carrying over, when do we do that? We do that, let's do 8, right? So we have this one. Again, what we do is we don't memorize doubles. We don't memorize the doubles. What we're going to do is we're going to understand how to add an 8. So we have the number 4. When I have the number 4, I want to add 8. Is there enough beads to add the 8? No, there is not enough beads to add the 8. So what do I do? What I need to do is I need to understand my formula, my number sentence. We're teaching the children this. We're teaching the children 2 plus 8 is equal to 10. That's great. But the thing is abacus makes it one step forward. What does the abacus do? Well, let's take our number. Let's take our formula. Let's take our number sentence, right? I think it's called number sentence. Let's take our number sentence. And what we're going to do is we're going to modify it. And we're going to modify and we're going to isolate this 8. Why are we going to do that? Because you'll notice I don't have enough beads to add the 8. But we can use the abacus to help us. To do that, we're going to do 8 is equal to 10. Again, this is not balanced. How do we balance this equation? Please put it in the chat what number we think we need to do to balance this equation. How do we balance this equation? Take away the 2. Yes, we're going to minus the 2. Thank you. So what are we going to do? How does that work? Well, we're going to add the 10. A 10 is a 1 and a 0. Remember when I said 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is 10? What we're going to do is we're going to add 10. This is 1 and a 0. So my question is 4. I'm going to add the 10. I'm going to take away the 2. So I'm going to add the 10, right? I'm going to add this 1 over here, and I'm going to take away the 2. My final answer is 12. No. 14 looks like this, Apple user. What we're going to do is we're going to add the 8. So to add the 8, we need to take away the 2. When we, yes, because you got to do the 2 steps, right? You got to add the 10 and you got to take away the 2. This is what we're doing is we're substituting this information into the 8. Does that make sense? So we can do it again. When we have 9, and we want to add the 8, there's not enough beads to add the 8. There's not enough beads to add the 8. What do? We know to substitute plus the 10 minus the 2. We're given directions plus the 10 minus the 2. So what is my final answer? Yes, you are learning abacus right now. You're learning how to add and subtract on the abacus. So what is my final answer? Can you please put it in the chat what the final answer is? 17. Thank you. No, you're welcome. Hey, no, welcome back. Thank you. Keep going. I can't buy an abacus. That's fine. That's fine. You don't need to buy an abacus. I just want to make sure you understand how to use the abacus. Thank you, Shane. Thank you, Apple user. I'm not here to, I'm here to explain how to use an abacus. 11? No, 11 looks like this. 1 and 1. That's what 11 looks like. So when 17, 1 and 7. Yes, thank you. The blue beads are 5. Thank you, Apple user. So we have 5, 6, 7. Does that make sense? Slackington, right? So what? Sacklington. So does that make sense? We have 1 and 7. 5, 6, 7. When we count, let's do a review. 1, 2, 3, 4. This is 4. And then we have the top bead. The top bead will always be 5, no matter what. So we have 5, 5, 5, 5, 5, 5, 5. These are all 5s. Now, when I clear it out, this is now 6. 5, 6, and then this is 7. 5, 6, 7, 8. 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Yeah? Does that make sense? So when I have the number 19 and I need to take away the 2, my final answer is 7. Good. So we have 5, 6, 7. And we have, I'm just joining. Why does 1 start? Ooh, that's a good question, Rachel. The reason why I start here is because I have this 1's indicator that's right there. So it's like a Pokemon, right? I choose 1 dot. I either choose this one or this one, and I choose this one. However, you could choose this one. You could choose, I don't know if that's, I think this would be like Pikachu would be over here, and Charizard would be over here. But you can only choose one. So when you choose one, and if you choose this one over here, then you move all your 1's over, your 1's, your 10's, but notice I don't have any more 100's. This is what we call a 1's label. It's just a label to tell me where the 1's is. So when we look, we have our 1's, our 10's, and our 100's. Now, we can stay here, but depending on how big the question gets, we get bigger numbers. So that's why I move it over here. That is why we start from here. So we use this as the indicator of my ones, and then from here we have our decimals. The period on top is a decimal, not a period. So when we have when we have a decimal, this would be my tenths and this would be my hundredths. The two, yes, exactly, Shane. Yes, thank you. The two right one over here is the decimals. So we have our ones, our tenths, and our hundredths. So when we look, we have 15. If I did that over here, then I have all of these numbers to be my decimal. I think see. Yes, thank you. No, that's a really good question. I'm happy that you're being observant, because some people just take it as it is. But that's why if this is this is interactive. I like the question so we can all talk about it. Let's do a review. It's the wow. It's on the right for 7 columns. Is there an abacus with more? Oh, that's a brilliant question. So this one has 7 columns, and you're right. This one has 13 columns. Why? Because size matters. Why does this matter? Because it just depends on how big the numbers get. That's all it means. That's all it means. So when we talk about it, this will be our ones. When we talk about it, this will be our ones. Let's say this is our ones. This is not holy cow. This is not holy cow. So this is our ones. If I showed you, it would be like this: ones, tens, hundred, thousands. Notice that we have every dot is every three is our column separator, right? So our column separator separates our columns. This is thousands. This is millions. How do we count it? Ones, tens, thousands, ones, tens, hundred thousands, 10,000, 100,000, million, right? There's another dot. Then we have 10 million, 100 million, billion, right? There's another dot. And then 10 billion, and I didn't do any more, but you know what I mean, right? So you choose yes, you could choose, yes, exactly. You could choose any one of these dots, any one of these periods. It's like a little Pokemon, right? I choose this one in the middle. So I talked about going to billions, and then you could go to trillions. But what? What? The what is, what if you want to track the national debt? Well, this is not enough, right? The national debt has more. So this is a 23 column abacus. Wait, I think I understand now. Yes, good. Thank you. This is made out of bamboo, and this has been with me for quite some time. Notice that the beads are a little bit smaller, and again, the beads have a little ridge. Because the beads have a little ridge, this is a standard size abacus. This are all standard sizes. What I'm trying to say is, it doesn't matter about the digits; it matters about the sizes, right? I'm talking about like the size and stuff. So you notice they're all about the same size. They're all about the same. They're all about the same height. They're all about the same. So these are all very similar. These are made out of plastic, and it works exactly the same. The plastic ones work exactly the same as this one. Where did you learn Soroban? I learned it here when I was in California. My dad went to Korea and said, "This is the greatest thing next to sliced bread, and I want to open up a learning center." And I said, "Okay." And I didn't even know what an abacus was. And he's like, "You're going to learn it because I want to do a learning center." And I'm like, "I don't even know what it is." So we opened up a learning center. I've been teaching abacus for about 20 years, and I do believe in the abacus now. I am now a new person that really enjoys the abacus. I didn't learn the abacus when I was young, but I have 3 boys, and all my boys know it. This is math. That's why you use it. Yes, thank you. Thank you, sweetheart, for I'm in Riverside County. Oh yeah, yeah. I'm in LA. Oh, okay. So, again, so what's going to happen? Oh, so I've been teaching abacus for about 20 plus years. I just recently started putting it on the internet, and so I'm just starting this new thing to educate the world. So the first thing we're going to do is understand that you have to be delicate. You have to be no, gentle. You have to be gentle with the abacus because it's very easy to move. Very, very easy to move. Have they put it have they put it in their heads? Do they need the Soroban anymore? They don't need the Soroban if they put it in their heads, but it does take a lot of practice. It's like playing the piano, right? Like you can kind of imagine the keys in your mind. It's the same thing. But it takes time and it takes practice. Do I? Oh, does my kids? I didn't push it. I didn't push it. So, they learned the basics, they learned how to add, subtract, multiply, and divide. And then when they finished it, I said, okay, let's keep going to more math, because this is not the end all, right? This is not the end all. The end all is what? More complex math. The idea here was to fill the gaps. Any gaps that might have happened between adding and subtracting, multiplication, division. We also, in abacus world, there's critical thinking, and so we add critical thinking to the skill of making of understanding how to use the abacus. I homeschool. I'm trying to teach my child. Oh, good. How old is your child? Yeah, you know what I mean. So, um, when they do like geometry, you can't do that on the abacus. If you want to do, complex algebra, right? We do a little bit of algebraic things, like we do distributive property, we do cumulative property, but for the most part, we stop at arithmetic. 7 years. Oh, that's fantastic. That's a good age. That's a very good age to start with the abacus. And so, let's do a review on how to read the abacus. So, to just a review on the abacus, we're going to count 1, 2, 3, 4. Now, why is this the greatest thing next to sliced bread? Because it's visual, as well as it's tactile, and you can see the numbers. Because if you notice, the numbers are very abstract. Like, you don't know what one is. So if the five isn't down, I'm sorry. So if the five isn't down from the right, are the ones on after that any meaning? No, because it's just like how we have our decimals, right? When we have our decimals, do we do 0, 0, 0? No, we don't. Um, Make sense? So when we do our decimals, do we always say 0, 0? No, we don't. We have whole numbers. So even if I wrote it out, right? Oh, I don't know, whatever. So we have like what, 10. But we do if we were to do money, we do this. But if we were to do, I don't know, 10, it's this is kind of the same. Yeah. Okay. No, no, no. That's not a dumb question. It's not a dumb question. There's no dumb questions. The only dumb question is if you never ask it, right? It's just about understanding, because it's a new thing. This is a new concept. Understanding that you could see your numbers is a very new concept. We have other things that are very tactile, but they're not the way the abacus is, which is very interesting. So no, I do not think it's a dumb question. The 5 beat is blue. Is less than 5, you don't need the blue. That's correct. So when we look, 1, 2, 3, 4, this is 4. So yes, exactly. So if you push all the beads down, it would be more than that. It would be 55,555.55. Yeah. This was the medieval was the what this was the medieval calendar. No, it's not medieval. Can you show a bigger number on the abacus again to show with the abacus? Oh yeah. So if I had a bigger number, you know what? Let's do some money, because I like money, right? If we had $5,438.14, right? So we would have $5,438.14. That's what it would look like. Yeah, yeah, not a problem. These are really good questions. So if I look, right, 14 cents, we know that it's 14 cents. This is a dime. I don't know where everybody is, so I'm going to assume this is a dime. A dime is 10 cents, right? This is 10 cents, so that's where this would be. This would be 10 cents. And then this is 4 cents. 1, 2, 3, 4, 4 cents, right? Every penny. So that's what, and if we think about it, right? If we think about it, this money is like cents of the dollar. That's why we would use it. Do you like the Japanese or the Chinese? I like the Japanese abacus more. I feel like the Chinese abacus is a little redundant. It's an ancient allocator, a calculator. Is it a calculator? It's not really a calculator, really. If you really want to get technical, it's not really a calculator. It's actually a tracker. But no, you're absolutely right. Thank you, my loser name. Yes, you're right. It's an ancient calculator. It's not medieval. It is ancient. Is it meant to be in a? It's not meant to be in a museum, but it is very functional. What is the best abacus to purchase to start? If it's a child, I would probably do the colorful one because it's nice and pretty, and then I would graduate them to a 13 one because the numbers get bigger. That's what I would do. How old are kids? It depends. I'm trying to start young kids as young as 3 years old. So that's why I have an abacus for preschool, preschool abacus for math. And then what this is talking about like what a number is, how does a number relate to an abacus, and so forth. So these are more like activities, how to do like numbers and stuff. And this one was like, oh, find the number 8 and then just follow a path. It doesn't matter what path it is, and then try to answer it. So that's what I would do. But it goes all the way to there's some big kids, right? So like I learned the abacus when I was close to 30 something. My kids started when they were about 4 or 5. We have a few kids that start at 7, 8. I would say 11, 12, 13 is a little bit sketchy just because that's where attitude sets in and they're like, this is too easy for me. I don't want to learn it. But then afterwards, when they start appreciating that they don't understand math, then they come back and it's kind of cool. So, um, so you could, I'm sorry. Oh, you should try and get Miss Rachel to give you an ad. I think she's too expensive for me. Ah, all those kids' brands need materials to buy. Okay. Have you ever heard of Vedic math? I have, Shane, I have heard of Vedic math, but I don't know what it is. There's also like finger abacus. I don't know what that is. And there's also a matrix, and I'm like, I don't even know what that is too. Somebody keeps asking me to put it in the matrix, and I'm like, I don't know yet. I'm not even there. I think it's immediately useful to show coins as analogy. If the people understand it, yeah. If some people understand the coins, then it does make sense. But not everybody is in America, right? So sometimes the coins don't won't make any sense. It would be better. It would make sense when we start doing it when we add the four. So if I had four, right? If I had four, I have four on my abacus. I have another four. I need to add a four, but I only have a nickel. Because I only have a nickel, which is 5 cents, I only have 5 cents, then we have to do a trade. When we do a trade, I'm going to give you my nickel, but I need to take away the one. So that's the same thing. I have my nickel, I add the nickel, then I take away the one. So my final answer is 8. So I do agree with the money as being analogy, which makes sense. But the first thing is to understand what the concept I'm trying to do is, what the concept I'm trying to teach, right? And then we can explore it further. Explore it further. But then going back to this, right? Knowing, understanding how to carry on a 10. It's the same thing. What we're doing is we're trading it in. And so what we did was, so we know how to do that. We can do a minus. Oh, I didn't do minus yet. So again, what we're trying to do is we understand if I want to take away, it's very similar. Notice this is the same thing. What are we going to do? We're going to do 17 minus 8. So if I have 17 on my abacus, I have 17 on my abacus, 1 and 7, right? And then I minus the 8. Notice when I minus the 8, it's equal to minus the 10. What does that mean? I need to take away the 10, and then I need to add the 2. I need to plus the 2. I need to plus the 2. So my final answer is 9. Again, this is how we understand how to read the abacus. We need to understand how to read the abacus, then we can move the abacus. So when we understand how to read the abacus, we can move the abacus. Does that make sense? So we're done. That is the secret to adding and subtracting. Hello, hello, hi. That's the secret to adding and subtracting. We will go into further. We're going to figure out how to Tetris our way through the system. But this is it. As long as you know how to add, subtract 5 and 10s, then we're good. We're golden. Are we ready for the next step? Are we ready for the next phase? Are we ready for the next, I don't know, yeah, stage, right? The next stage, the next phase, the next, I don't know what to call it, the next thing. How have I been? I've been really good. Yesterday was a little hairy because I was reading a comment and I felt a little salty, but I have to remember that there's a lot of kids. There's a lot of kids that comment. I appreciate the comments, but sometimes it rubs me off the wrong way. It's sometimes, you know what I mean? Like, because they'll be like, what's the point of this? We can already know how to do this. And that's where the attitude sits in. You want to show division already? Are we ready for division or do we want to do multiplication? There's a thing called two step. All right. What do we want to do? Shane wants to do division. Are we ready for division or do we want to do multiplication? How are we doing? Can you I'm sorry, you can show you understand by just giving me the answer. you can show, I'm sorry, I don't even know what that meant. Multiply is easier first. All right, let's do multiplication. Because division is a little bit, but we will get it. Okay, but Shane, I think I have enough time to do division, so we will be able to do division in a little bit. Okay. This will be, obviously, this will be easy multiplication. Why? Because we just need to know how to add. When we do it, we want to understand what? In abacus world, we do not need to know anything higher than 9 times 9. All right. So the first thing we're going to do is understand here is 39 times that by 7. When we do multiplication, when we do multiplication, what are we doing? When we do multiplication, there we go. There we go. There we go. Okay, multiplication. So when we do multiplication, what we're going to do is we're going to understand. I need to. Where's my? Oh, there we go. We're going to understand how to. I lost my words. I'm sorry. We need to add. We need to find our answer. When we find our answer, then we're going to put it somewhere. So what does that mean? We're going to count our digits. We're going to count 1, 2, 3. When we count it, so we know we're going to be somewhere in the hundreds. 1, 2, 3. When we have the number, we're going to be somewhere in the hundreds. Where is my? There we go. Right. So when we look at it, we're going to be somewhere in the hundreds. Our number is going to be somewhere in the hundreds. Now, when we work with it, it looks like it's new math, but it's not. It's actually abacus math. What does that mean? Well, in abacus world, what we're going to do is we're going to do distributive property. Distributive property means what? We're going to take one number and we're going to multiply it out. And then we're going to take another number and multiply it out. So the first number we're going to do is 7 times 3. Notice I do 7 times 3. I am not going to say 7 times 30. New math talks about 7 times 30. Why? Because they have to write it out. But in abacus world, we don't need to worry about 7 times 30. We need to know 7 times 3 is 21. So remember, I have 1, 2, 3. When I put 21, now I don't have to worry about where my abacus is. I already know that it's 210. But in mainstream math, in new math, they need, if they write it out, you need to have 210. But notice I have 210 here, but I have it on my abacus. I don't need to do it anywhere else, right? So the next one we're going to do is 7 times 3. 7 times 3, no, 7 times 9 is 63. I add my 6, and then I add my 3. So my final answer, what is my final answer? What would be my final answer? Please let me know what my final answer is. 273. Yes, thank you. Thank you, Tammy. Thank you, Shane. Thank you, Apple user. Right? So make sense? So what we're doing is we're understanding how to multiply on the abacus. And it's the same concept. We're going to still have to find our numbers. So when we do multiplication, we need to know how to find where to place our numbers. We can do another one. We can do 47 times that by 4. Same thing. We're going to clear our abacus and we count 1, 2, 3. Oh, right? 1, 2, 3. When we count 1, 2, 3, 1, 2, 3. So our number is going to be somewhere around here. Somewhere around here. 1, 2, 3. So we do 4 times 4 is equal to 16. So we do 1, we do 6. And then we do 4 times 7 is what? 4 times 7 is 28. I add 2, I add 8. Yeah. Guys, you can count the beads that touch the metal. Yes. Right? Does that make sense? So what did we just do? What we're doing is we're checking to see if we have enough beads. Again, if we have enough beads, then we just add it. If we don't have enough beads, then we have to start using How was that 8? Why make math harder? How is that 8? Oh, 5, 6, 7, 8. That's how that is. Is it? Thank you, Apple user. Yes, 5, 6, 7, 8. 5 plus 3 is 8. So when we look, we have 1, 2, 3, 4, and then we have 5. 5. Thank you. Yes, blue B counts as 5. So this is 5. And then we have 6, 7, 8, 9. After 9, we have 10. So when we look, every place value, right? Every place value, every column is a place value. Thank you, Apple user. Every column is a place value. So we have our ones, our tens, our hundreds, our thousands, our 10,000. When we look, we're going to start here. We have our ones, and this is the ones indicator. The ones indicator is where we're going to start our ones. You could start here, but we're going to start here because our numbers are going to be bigger. Okay, good, Carla. Okay, good, Carla. Thank you. So does that make sense? So what we're doing is we're learning how to read the abacus. After we read the abacus, we go into adding and subtracting, but we kind of moved over and we went all the way to multiplication. So the first thing we're going to do is understand how to multiply, right? In abacus world, we don't need to do anything higher than 9, right? The reason why is because it gets redundant. And what we were just doing is we're doing multiplication. You could do it the old way, right? Or you could do it the abacus way. It's up to you. But I'm just showing you a different way. That's all. Should we go more division, or should we go 10 times 10? So that's easy, right? It's still the same thing, right? You still need to count it out. 10 times 10, right? So when we look at it, 1, 2, 3, 4, 1, 2, 3, 4. When we do that, we do 1 times 1. 1 times 1 is equal to 1. 1 is a single digit. I go back one column and I add the 1. So then I know my full answer is going to be 100. Does that make sense, Shane? So we have to remember that if it's a 1, if it's a single digit, anytime it's a single digit, you go back one column, because the idea is you want to do you want to make a 2-digit number. Yeah. So just like when we do time, when we talk about time, right? We do a 1203, right? This is a 2-digit number. So what we're trying to do is we're trying to make our numbers 2-digit. Sometimes the leading zero makes sense. Sometimes it's just understanding to go back one column, right? We could do, I mean, it's the same thing. We could do the same. Yeah. Easy, smooth. It's almost like multiplying in binary. Almost. I don't know binary. I try, but I don't know binary. I couldn't wrap my head around that one. Um, Yeah. So then, I mean, we could do more questions, right? And then obviously it becomes scalable. We could do, 55 times that by 3. And then what do we do is we break it apart. We break it apart. We can do bigger numbers, right? So let's say we did 55 times that by 30. Oh, no, let's do 56. Let's do 56 times that by 34. We do the same thing. When we do the same thing, now we're going to get a little bit bigger. We do 4 digits. 1, 2, 3, 4. When we do 4 digits, right, what are we going to do? We're not going to, I don't know how they do it. Oh no, you know how they do it in they do it in new math. They do new math. They do this. They do 30 times 50, right? So 1, 2, 3, 4. But notice in abacus world, we don't need to do 30 times 50. All we need to do is 3 times 5. 3 times 5 is equal to 15. So I add 1, I add 5. That's it. But here in mainstream world, we got to do 1500. That's not hard at all. So then what are we going to do next? What are we going to do? We're going to do 3 times 6. So 3 times 6 is equal to 18. So we add my 1, we add my 8. Oh, that's not 8, that's 8. Again, what are we going to do? In mainstream math, we got to do 30 times 6 is equal to 180. Okay. We're done with the 3. Same thing with the mainstream math. We're done with the 3. Now what are we going to do? We're going to count it. 1, 2, 3. 1, 2, 3. So what are we going to do? 4 times 5 is what? 4 times 5 is equal to 20. I add 2, I add 0. Mainstream math, what do we do? It's 4 times 50 is equal to 200. But notice I don't need to do 200. I just put it on my abacus. So then what are we going to do? 4 times 6 is what? 4 times 6 is 24. 4 times 6 is equal to 24. This is a little bit, why? Because we didn't go, we got to do some formulas. We want to add the 2. There's not enough to add the 2. We know how to add the 2. To add the 2 is we're going to be adding the 10, right? We need to add the 8. We need to plus the 10 minus the 8. So we're going to plus the 10 minus the 8 and then add the 4. So my final answer is 1,904. That's what my answer is. 1,904. Right? So why are we learning it this way? We're learning it this way because it's scalable. Now it doesn't matter how big my number is. I can scale it. It doesn't matter. We can just do it on the abacus. And that's the thing. It automatically allocates the place values while at the same time teaching place value gene. Yeah, right? But it's based 100. Yes, thank you. Yes, it is based 10, not binary. Exactly. It is straightforward. It is straightforward. It is straightforward. It's interesting, right? That, but see, the thing is we jumped a few steps, right? Because some people don't have the patience to learn the basics. Like, I'm not saying you guys. What I'm saying is, like, we already know what 4 plus 4 is. Well, no, hold on. Very streamlined. Yeah, unlike the Japanese, Japanese perfection, efficiency. The Japanese make it efficient. They make everything efficient, right? No, I'm only commenting on like the comments that I get in my posts, right? We're learning multiplication. Hey, Kat, welcome back. I too used to quick pen and paper math. Yeah, right. So what we're doing is, yeah, you could do it pen and paper. That's fine. They're teaching new math is this way, which is interesting because that's really abacus math, just on pen and paper, which is interesting, but nobody goes back to the abacus because nobody knows how to use it, right? So what my goal is, that I'm hoping that everybody understands what the abacus is and what we're trying to do, right? So we start off with the basics and we understand how to make a 10. After we make it, no, the first thing we need to do is understand how to make a 5, right? And then we make a 10, and then after making a 10, then we do multiplication. Save some paper. Yeah. Saving paper, yeah, because you can do it on the abacus, and you can see it, right? So we can do another number. Are we ready for more multiplication? Or are we ready for division? Right? We could do bigger numbers, but it all translates onto the abacus. Knowing how to do the adding and subtracting of the 5 and the 10. More, please. All right. I don't have one just lying around. All right. So what are we going to do? Well, again, I'm going to show you the greatest thing. When we do this, right? Again, we're going to count our digits. When we count our digits, we have 1, 2, 3, 4, 5. We have 5. Now we have 5 digits. 1, 2, 3, 4, 5. I don't know if that's enough. Let's check. So 7 times 9 is equal to 63. We add 60, we add 30. And then what? 9 times 2 is 18. 9 times 2 is equal to 18. So I add 1, I add 8. We're done with this. We're going to count again. The hardest thing to teach kids is place value. This is so intrinsically. Yeah, exactly. So we have 1, 2, 3, 4. 1, 2, 3, 4. You know what I did here? I did hear subtraction's really difficult for kids too. So 3 times 7. 3 times 7 is equal to 21. Ha! 21. 21. Do we have enough to add the 1? How do we add? I'm sorry. How do we add the 2? Do you remember how to add the 2? What can we do? We can utilize the 5. We can utilize the 5. Count the numbers, you get your place. Yes, exactly. Count the numbers, you get your place. Right? So 1, 2, 3, 4. 1, 2, 3, 4. We're over here. We're going to add 21. 21. Add the 2. Do you remember how to add the 2? Do you remember how to add the 2? Right? We can do it with the 5. We can do it with the 5. Plus the 5 minus the 3. And then we're going to add 21. That's our 1. Then what are we going to do? 3 times 6. 3 times 2 is equal to 6. 6 is a single digit. I go back one column. I add the 6. Yes, thank you, Shane. Yes, right? Now we're done. We're done with the 3. Now we got to count again. 1, 2, 3. 1, 2, 3. I'm over here. 9. Woo! 7 times 5. 7 times 5 is equal to 35. I had 3. I had 5. I had 3. There's not enough to add the 3. I know how to add the 3. I'm going to plus the 3 is equal to plus the 10 minus the 7. I'm going to plus the 10 minus the 7. And then I need to add the 5, right? I need to add the 5. So I'm going to add the 5. There's not enough to add the 5. What do I do? Plus the 5 is equal to plus the 10 minus the 5. So I'm going to plus the 10 minus the 5. 5 times 2 is equal to 10. I'm going to just 5 times 2 is equal to 10. Is there enough to add the 10? Yep. Add the 10. 1 and 0. So my final answer is other and the remainder. Yes. Thank you, Apple user. Exactly. So my final answer, oh my gosh, what is my final answer? My final answer is 67,320. Right? Cool? How are we doing? Hey, welcome back, Mel. Welcome back. So what do we just do? This is the power of abacus, right? Thank you so much for the hearts. This is the power of the abacus. But obviously, I'm giving you like a huge master class, and we're just blowing through all this information. There's a lot of information. I'm not saying that it's not hard, but it's not easy either. You know what I mean? You got to put some practice into it. Just like how we do everything else in math, right? Everything else in math is all about practice and about getting it. It kind of understood that, right? I'm telling you. I'm telling you. It's very intuitive. It's amazing on how it is, right? We can do something smaller. You want to do something smaller? We can do something smaller. We can do 4 digits, or we can do 3 digits. We can do 3 digits, right? For multiplication, we can do 3 digits. Can you throw in some decimal? Yes. I'm going to take a bit to read it, like the numbers on a page, but it's not hard. Yeah, exactly. Yeah, you know what? Honestly, I still take time to look at the numbers to see what I'm reading. So it's still, I mean, I've been doing it for 20 years, but it still takes time for me to, because it's not part of our everyday thing, but it does take a little bit. So, I mean, the digits. Oh, here we go. We do mm, 65 65.3 times that by 40.2. Same thing, right? So what are we going to do? We're going to count, but this time we're going to count just our whole numbers. 1, 2, 3. So we can start from there. 1, 2, 3. 4 times 6. 4 times 6 is 24. Add the 2, add the 4. 4 times 5 is equal to 20. Add the 2, add the 0, add the 2, plus the 5 minus the 3, add the 0. 4 times 3 is equal to 12. Add the 1, add the 2. We're done with this. So we go one more down, right? We're at the 2. So we do 2 times 6 is 12. 2 times 6 is 12. Add the 1, add the 2. 2 times 5 is 10. Add the 1 and the 0. 2 times 6, I'm sorry, 3 times 2 is equal to 6. 6 is a single digit. I go back one column, I add the 6. So my final answer is 274.26. I hope that's right. Was that too fast? Let me know if it was too fast. I can go slower. Hey, Trey, welcome back. Thank you for the share. Let me know if that was too fast. I can go slower. When I get new questions like this, I always go a little bit faster because I'm trying to go through it. Hey, Panda, welcome back. I'm a bit lost there. How do you do the places? Okay, let's take it a little bit slower. Okay, I need to do a run through. Okay, so we'll go back. 653 times that by 4.2. Now, because there's decimals, it's a little different, right? Because there's decimals, we're going to kind of ignore the ones over here. We're going to count 1, 2, 3. That's how we're going to do it. Yeah. I just mailed it out today, so you might get it within the end. well, this is Friday, so you might get it next week. And then I just made, and then, yeah, and then I have your little booklet too. So I hope you like the booklet. I really like the booklet. I added more to it because I was like, oh, let me show you what I added. So I had the little thing, and then I have it where you have the computative property, and it'll show you how to do the making of the 10, and also making of the 5, and making of the 10. And then what I did was we had the plus the tens, and you have a little thing here. I stuck it, and I noticed I like it. So I have a little indicator on the side, so it can kind of tell you what you're looking at, and then there's the indicator on the other side. And then what I did is I separated it between the tens, and then again you'll have a little sticker here, not a sticker, but a little indicator like what number it is. So it'd be plus the 10 and plus the 9, and that's what's going to be written right here. And then towards the end, I actually added the abacus framework towards the end. So it will tell you how to move, right? It will tell you if you have enough beads, you will go to here. If you don't have enough beads, you go to here. And so I added that into your book. You will have that there. I'm really happy with this product. And so when you have enough beads, do you go here or do you go here? And I felt like that this was a really good touch to it. Yes, no, thank you. Thank you. I hope you enjoy it. And it is laminated, so you can write on it and use a dry erase. And again, there is the minus one. So you have the adding one and you have the minus one. And I have all of the formulas there. The flow chart is very good. Thanks. Yeah, not a problem. Is there a need for a bigger abacus? The only need for a bigger abacus is if your numbers are bigger. I got dry erase markers for it. Oh yeah, good. That's a nice resource. Yes, thank you. I appreciate that. I think it's a really nice one, especially since and then here I try to make sure that I have the proper wording. So we have to isolate the variable, and then we want to subtract it if we want to make it by itself, and then write the cumulative property. Because the reason why I want this is I want to make sure that we understand that sometimes we need to have it one way or the other way. So I didn't want it to be only one way. I wanted to make sure that it goes both ways. So yeah, I'm really happy with this one. I appreciate everybody that's here. It is everything. It's all laminated and it's a spiral bound. Yes. If you show division, can you use extra decimal rods? Yeah, but you can, but I wouldn't do that right now. I do it a little bit later. Oh, sorry, we're back to here. So when I count it, I count one, two, three. And notice I kind of ignore this, right? Why? Because this is where the number I was trying to figure out how to make it easier and how to relate it to mainstream math. And you know how in the mainstream math we have number line, we have two, I'm sorry, minus one, minus two, and then we have a zero, and then we have one, and we have two. We're gonna have to kind of think of it that way. That's only three. So why only three? Because the whole numbers are only three. There's only three whole numbers. One, two, three. That's why we only have three whole numbers. One, two, three. Does that make sense? So when we look at it, we're going to do 4 times 6 is equal to 24. Yeah. Decimals gets a little bit tricky. It gets a little bit tricky, but I think doing this number line makes sense. The only two decimal digits go right, not to the left. Oh yeah, right. Yeah, I mean, but the number line, when we do number line, you have a minus on this side and you have it adding. I'm just showing the number line. That's all I'm doing. This is just a concept. I'm still trying to figure out how to explain it. But when we do it, right, it would look like this. It'd be I guess it would be like this. It'd be 2, 1, 0, -1, -2. Well, it wouldn't be minus. It'd be one, and then it'd be two. That's what it would look like. That would be our number line. Why? Because we got it. Because when we go more is when it gets like kind of, yeah. So the total five is there's a three whole numbers, like you said. Yeah, yeah, yeah. Doing it, I think this way is, but yeah, I'm still trying to figure out how to explain that with mainstream math. So we have the three, 24. So we're going to add 20, we add 4. We're done with that. Then we go 5 times 4 is equal to 20. 20, 2 and a 0, 2 and a 0. Do I have enough to add the 2? I don't have enough to add the 2. What do? I know 2 is equal to plus the 5 minus the 3. So if there was hundreds on the question, wouldn't there be enough? There wouldn't be enough places? No, there would be enough. So you're right. There wouldn't be enough because we'd be over here. Or you could start over here. But that's why it depends on your question, and we'd start on the 13, right? So like fourth graders, fifth graders, they start doing decimals. I think they're doing decimals in fourth grade. So that's when they would graduate to the bigger abacus. So let's say, okay, so what are we gonna do? Let's redo this. Six, 5, 3, 4 times that by 2, 3, 6, right? I meant there wouldn't be enough yeah, you're right. There wouldn't be enough decimal places. You're absolutely right. You're absolutely right. Right? So even if we did this, we're going to count when we first start it'll be 2 because we have 1, we have 2. And then as we go through each number, we're going to subtract, right? So we're at 2, 1, 2. So we go over here. So 2 times 6 is 12. 2 times 5 is 10. 2 times 3 is 6. So 6 is single digit. I go back one column, I add the 6. 2 times 4 is 8. 8 is a single digit. I go back one column. So notice that we did this, right? Now what are we going to do? Well, you can either, you started here at the 2, you can go back 1, or you can count it, which would only be, since I'm done with that one, it would only be the 1. But then it gets a little hairy about here. So let's start from here. We're at 1. I'm going to change color. 1, we're at here. 3 times 6 is 18. I add 1, I add 8. 3 times 5 is 15. Equals 15. I add 1, I add 5. Not enough to add the 5. Ha 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 ha. Not enough to add the 5. Okay, this is where it gets a little hairy. Why? We want to add the 5. Plus 5 is equal to plus 10 minus 5. I'm going to minus the 5 plus the 10. Plus the 10. Can I plus the 10? No, I can't plus the 10. What do? I need to plus the 1 is equal to plus the 10 minus the 9. Minus the 9 plus the 10. I can't plus the 10. What do? Plus 1 is equal to plus 5 minus 4. Plus the 5 minus the 4. I'm done. And then, what do? 3 times 3 is 9. 9's a single digit. I go back one column and add the 9. Yep. So I add the 9. Plus the 10 minus the 1. And then 3 times 4 is 12. Add the 1, add the 2. When I'm done. Now what do? Now if you notice, there's a 0 and a 1 here. There's a 0.06. There's a 1 where we don't go 1 anymore. We got to go 0 because now it's what? This is where I get a little hairy. It's like minus 1 and 1 is equal to 0. So we're going to actually start here. That's why it's a number line. I don't know. I got to figure that one out a little bit better. I just know to do it. I don't know. I don't know how to tell you. 6 times 6 is 36. So add the 3, add the 6. 6 times 5 is 30. Add the 3. There's not enough. Plus the 10 minus the 7 plus the 0. We're over here. 6 times 3 is 18 plus the 1 plus the 8. There's not enough. There's not enough to plus the 8. So what do? Plus the 10 minus the 2. Because we're plussing the 8. Minus the 2 plus the 10. Not enough. Minus the 10 plus the minus the 9 plus the 10. Okay. So we're done with 8. And then what? 6 times 4 is 24. That wasn't difficult at all. But again, it goes back to we need to really understand how to add the 5, add the 10. And when you know how to do it, then it's easier to go through all of this. And it's tougher because now the colors are all the same. So, what is the answer? The answer is 15.42024. I think that's it. I think that's it. I think that's my answer. Uh, 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 but it's a little difficult to present and do the question. Hey, Mr. Clean, welcome back. I hope the addition is critical multiplication. Yes. Knowing the addition is critical for multiplication. Yes. But see, what I'm trying to do is I'm trying to figure out like when we get to like something like this, right? When you're done with 203, we're done with this, done with this. Now we're at the minus one, and then we take away the one. That's how we get 0. That's why I was trying to do a number line. I don't know. I'm still trying to figure out how to explain it, but I think that's the closest thing I can get. Because we would talk about the number line, how there's 2, 1, and then there's 0, and then there's minus 1, minus 2. Even though we don't do minuses in abacus world. Well, we kind of do, but we don't do imaginary numbers. I don't know if that made sense. I'm still trying to marinate on how to explain that in mainstream math. But like to me, because I know it, it's like, oh, okay, I just take away one and just take away one. But I would like to explain it better. Thank you so much for the hearts. Thank you so much for the hearts. I hope that made sense. But those are your decimals. And I just continue it on. All right. Oh, are we ready for division? Division's a little bit as well. How are we doing on time? Okay. Woo, we're doing pretty good. How are we feeling? I mean, there's a lot. That was a lot. How are we doing? Do you want to do division? Are we ready for division? Looking at your paper on my make it look like hieroglyphics. Yes. Friday. Do you have plans later? I do. I think I can come back on tonight. I should be able to come back on tonight. I've been waiting for this. Okay. Yo, Ghosty, welcome back. Okay. So the first thing we're gonna do is understand what. Okay. Let's let's do this one. When we do division, places. Yes, we're gonna do places. So in division, we have to understand. Again, I'm going to use simple. I mean, obviously, we could do this in our head, right? Finally, I have an abacus to practice with. You guys are so awesome. I really appreciate everybody that's here, that are open to learning how to do new things or learning how to do abacus. Because it really is very, it helps my soul when I hear you guys super excited. I'm letting you know that it makes me so happy that you guys are excited to learn about abacus because then I feel like my effort is not wasted. You know what I mean? Like, oh, some of those questions, some of those like, ugh. Anyways, some of those comments, they kind of, yeah. I have to start ignoring those comments. I have to realize they're young. Kids are young. Okay, the first thing we're gonna do is understand we have a divisor and we have a dividend, right? We understand that. Oh, thank you, Kat. Thank you. I appreciate that. I know, but it's very it's encouraging because you guys are so supportive. You know what I mean? If you guys were never around, I don't think I'd be doing this as long as I have been. I've been doing this for what, 3, 4 months now, and I go on live at least once a day. Oh, before I forget, for those of you that are here, and I'll put it in my story, I'm taking next week off because I have to go to science camp with my kid. So I'll be in science camp and I won't be able to go live next week. Just so you know, having good tools to do basic math is just everyday important life. Yeah, right. And that's what it is. It is. I think it's a really good tool. But just so you guys know, I will be out to science camp before I forget. I'm going to go to science camp all next week. So I will. I'll be doing another live Saturday, Sunday, and then I'll be out Monday, Tuesday, Wednesday, Thursday, and I'll be back on Friday. You'll get my abacus. Yes, yes, you will get your abacus. So have a good time. Yeah, thanks. This is my third time going to science camp. Yeah. Yeah. So cuz I have three boys and every boy went to science camp cuz the school offered science camp. So I was like, "Okay, I will go." All right. When are you coming? I will be there in a half an hour. No, I'll be there. Oh, I'm sorry. I will be there about 1:45. Yep. So, yeah, I have science camp. Yeah, have fun. Thanks, thanks. But yeah, I'll put it in my story to say that I'm out to science camp. But I have to remember to let everybody know because I feel like I'm getting to a point where people are kind of expecting me, and this is kind of weird. Okay, are we doing division on the abacus? Yes, we are. We are going to do division. Is this a math tutoring stream? Oh, maybe. I don't know. It could be. It could be a math tutoring stream. I know I've been teaching abacus. That's what I've been trying to do. Thank you, Ruli, for the question. Is it a math tutoring? Well, what is tutoring? Tutoring is like teaching. Teaching is, I don't know. I think so. Okay. Well, but no, I don't think it's a tutoring. I think it's more teaching, and showing how to do abacus. That's what I'm doing. I'm showing everybody how to do abacus. Okay, the first thing we're gonna do is again, we need to understand is what is. I've learned so much. I wish I knew school. Yeah, right. I wish I knew this was in school too, but it was just so amazing. Like when I first learned it, I was like, oh my god, this is so cool. So the first thing we're gonna do, remember. Okay, remember and I know I teach differently than when I was taught. And the reason why is because I always want to know why. So remember in multiplication, we added our numbers. What we're going to do is we're going to subtract our numbers. We're going to subtract our dividend from our divisor. We have we have one divisor, and we have two dividends. So 2 take away 1 is equal to 1. Do we get that number? Do we understand how we got that? Thank you so much for sharing my live, Tatiana. Why are we going to do that? The reason why is so we know where to put our quotient. When we put our quotient, it's going to be in the ones column. It'll be over here. So I'm going to move everything over like that. So the green, right? The green is my quotient. This yellow something something is going to be is going to be my dividend. So I'm going to put my dividend on my abacus. That's what I'm going to do. I'm going to put my dividend on my abacus, right? And then what are we going to do? The first thing we're going to do is we're going to understand. We're going to compare. We're now going to have a conversation with our abacus. We're going to have. I'm sorry. We're going to have a conversation with our question. We don't do this in mainstream math, which is very interesting. So when we compare, we have our divisor and we have our dividend. When our divisor and our dividend is the same, right? We got to go to the next one. We're only going to go to this one here. We pretend that there's a 0 here, but we know there's an 8. So 0 and 8. We know that 8 is bigger. If 8 is bigger, then we're going to skip this column and we're over here. Where quotient's going to be here. And we're only going to utilize one column. That's all we're going to do. So when we have our question, we're not going to be like, how many times does 2 go into 28? We're going to go easier than that. We're going to go smaller. We're going to be like, what times 2 is equal to 2? Because we only need to know what this one column is. Make sense? We don't need to do 2 columns. We only need to do 1 column. That's enough. We have enough to do 1 column. So 1 times 1 is equal to 2. I put 1 here. That's where my quotient is. And then I take away 2, right? Because just like we do division, I am lost. Okay, I got it. I got it. Let me finish my thought, and we'll go back. We'll go back slower. Let me finish it out. So I have 2, right? 2 times 1 is 2. I'm going to take away the 2. I'm done. Now I got to do is I have to compare again. When I compare my 2 and I compare my dividend, which is 8. 2 and 8. Who is bigger? My 8 is bigger. So what am I going to do? My question now is how many times does 2 divide into 8? 2 times what is equal to 8 or less? 2 times 4 is equal to 8. So I take away the 8. So my final answer is 14. Thank you, Marco. Yes. Okay, so let's go back. How did that work? How are we doing on division? Let's go back. We will do it again. Yeah? Okay, let's do it again. That's what I'm saying. Division's a little bit, but once you get the basics, then it'll be easy. We take away the 2 because we would substitute in long division. Yes, I understood it. Yes. So let's do it again. So yeah, we're doing a version of we're doing a ver a version of long division. Yes, exactly. What is an abacus for? An abacus is to track your numbers instead of writing it out. That's what an abacus is for. We can Let's review how to count, and then we'll go into doing division again. So when we count, it's 1, 2, 3, 4, and then we have 5, 6, 7, 8, 9, and then we have 10. So notice we have 10. Every column is a place value. So if every column is a place value, all we got to do is it tracks our numbers. That's what an abacus is for. It's just to help us track our numbers, right? So we have 10, 11, 12, 13, 14, and then we have 15. Does that make sense, Marco? And then we have 25, 35, 45, and then 55. So that what we're trying to do is I'm trying to show how to use the abacus when we add, subtract, multiply, and divide. I'm actually towards the end, and we've gone into division. So I appreciate your answer, but I was doing it through the abacus way because when we do it the abacus way, then it becomes scalable. So I'm trying to teach the basics of how to do it on the abacus. If I taught bigger numbers, that would lose people more, right? So I appreciate your patience. Okay, so what we're going to do is okay, I got it. I got it. So let's do it again. So when we do it again, we're going to do 2 divided by 28. What are we going to do? Okay, got it. Are these lessons in a formula book? This one, division, is not in the formula book. The formula book is only right now for adding and subtracting. So this is only for adding and subtracting, adding the fives and adding the tens. And this one's only the formulas. It's not the actual questions themselves. The questions are in a different one. Oh, it's it's the Bible, by the way. Okay. Okay. So what are we gonna do? So we're gonna go back to here. CompuBear, okay, you understand this part. Do you understand when we do the comparison? Maybe we do a different number. Let's do it. Maybe we do a different number. Maybe that would be better. Maybe this one would be better. Maybe this one would be better. 157 divided by 7. 154 divided by 7. Maybe we'll try that. The comparison lost me. Okay. Yeah. See, it takes a little bit. It does take a little bit. So the first thing we're going to do, okay, here, the first thing we're going to do is understand where are we going to put our answer? Where are we going to put our answer? We got to figure it out. 1, 2, 3. 3 division, right? 3 dividends minus 1 divisor. Then we know our place value is going to be 2. 1, 2. So we're going to put our answer here somewhere, right? Oh, you didn't see that. There we go. Right? Okay. Okay. Let's see if I can write it better. See, that's the other thing is I'm trying to practice how to write it better. Why? Because in regular math, we're always like, well, how many times does 7 go into 154? And then what do? They go, okay, 7 times 7 is equal to 49. Well, you need more than that. Then you got to go like, I don't know, I don't know how they do long division. I forgot how they do long division. I only remember how to do it in Abacus World. So in Abacus World, what we do is we compare the one digit. We do one digit and one digit. We always want to compare apples to apples, right? So if we have our dividend and our divisor and our dividend, right? What is our divisor? Our divisor is 7. Does that make sense? And our dividend is 1. We only do the 1. We only need to do 1, so that, right? Why are we comparing? We need to know if we have one digit or 2 digits. That's why. No, I don't understand the comparison. Okay. We need to, yes, exactly, Ashley. Ashley. Yes, we're doing one digit at a time. Right? We're only doing one chunk. We're breaking it. What was it called? I don't know. I think it's called partial quotient. I don't know. 7 is bigger. Yes, thank you. 7 is bigger. Because 7 is bigger, now we know we're going to take away 2. We're going to use two digits. Why? Because when we do it, we're going to do 7 times what is equal to 15 or less, right? It is different than normal math. Well, no, it's very similar to new math apparently. Yes, exactly. 7 cannot go into 1, so has to go into 15. Exactly. Because the 7 is bigger, because the dividend is bigger, we need to do 2 digits. Exactly. Yeah, Tatiana, you know what I notice is old math and new math. New math is very similar to abacus math, which makes me mad. Yes, thank you, Ashley. Yes. So because 7 cannot go into 1, what are we going to do? We got to take two numbers. Does that make sense? Once you understand it, yeah, it gets very simple. Yeah. Yeah, thank you. Yeah, thank you, Shoemaker. It's very interesting. It's very interesting. When I started looking into new math, they are doing it the way abacus is. So, and then there was the other thing is I was reading up. It's good to know how to do long division because it works into more complex math. So, cat and CompuBear. How are we doing on this right here? Does that make sense? Okay. So now what we're going to do is we know we're going to put our answer here, right? Oh, I need to put in 154. 7 times 2 is equal to 14. I'm old math. Yeah, I'm old math too. Okay, we know we're going to put our answer, our quotient is here. We're going to put our quotient here. We're going to put the quotient here. Okay, and we're going to take it away here. We need to take away 14. Take away 1, take away 4. So what do we have left? We have 1 left, right? If I did this, 1, we don't bring down the number yet. We're going to compare 7 and 1. Who is bigger? 7 is bigger or 1 is bigger? 7 is bigger. Guess what? Now we know we need to bring down the 4. We need to utilize the 4. We're going to take these two digits right here. There's no bringing down. I mean, in the paper, right, you bring it down. But if you notice, it's either 1 or it's 14. So 7 times what is equal to 14 or less? 7 times 2 is equal to 14. Take away 1, take away 2, take away 4, take away 1, take away 4. Yeah. How is that? Was that better? So in long division, we bring it down. But in abacus, yes, the final answer is 22. Yes, the final answer is 22. In long division, we bring it down because we're on paper. But in abacus, we have it on here. So we look, 7 times 1, there's not enough. So that's why we have two digits. Yes, I understand, right? It's a different way of thinking, but we break it down into manageable chunks. We don't need to say how many times is 7 going to 154. Can we divide more? Yeah, we can. We can divide more. But do we understand the steps, Ollie? Do you understand the steps? Because it's the steps that matters. Once we understand the steps, what do they call it now? They call it procedural fluency. Do a problem just on the abacus. Okay. the steps make sense. Yeah. Okay, let's do another one. 195, divide that by 5. Okay, so we know 1, 2, 3, and then 1. So we know we're going to be at the 2, right? We know our divisor is 1, our dividend is 2, right? Well, I just came in. I don't remember from before. Oh, Ollie, Bible is trying to get the steps. Bible is trying to get the steps. Hi, Ollie. Okay, let's do a review, how to read the abacus, and then we'll go into division. So, 1, 2, 3, 4, 5. When we do place value, 6, 7, 8, 9, and then 10, 11, 12, 13, 14. Does that make sense? 15. That's 15. We have decimals. This is my ones, my tens, my tenths, and my hundredths. Hundreds, thousands, 10,000. Does that make sense, Ollie? So what we're doing is we're just reading the abacus. And so we're moving ahead. Okay, good. Okay, so then we're going to do some division. 39? Maybe? All right, so we're going to do it. So we have 2. We're going to put our number in 2. 1, 2. How do I know? Because I have 3 digits here. I have 1 digit here. 3 take away 1 is equal to 2. So my answer is going to be here, 2. So my quotient is going to be there. So what times, who is bigger, 1 or 5? 5's bigger. So I know I'm going to take 2 digits. 5 times 9 is equal to 15 or less. So I'm going to put in my number 195. So I know 5 goes into 15. Sorry, 3. 3 goes into 15. Take away 1, take away 5. And then what do I have? 5 and 3. I'm sorry, 5 and 4. 5 and 4, who's bigger? 5 is bigger. I'm going to be here. 5 divided by 45 is 9. So it is 9. Thank you, Kat. There we go. Yep, 39. I don't know if that helped. I don't know if that helped. That was too fast. Okay, yep, let me do it again. Let me do it again. Let me get more paper. Sorry. Okay. I like the steps. Why? Because the steps make it slower for me. Okay. And it's just easier for me to slow it down a little bit. Right. So divisor and dividend. We're going to do a comparison again. Right. When we do a comparison, we know what are we going to do? We have 1, 2, 3, but 2. So we're going to be here. Our quotient's going to be here in the second column. So we add my dividend. My dividend is 195, right? I have 195. I'm going to compare. I have to compare apples to apples. So when I compare apples to apples, S and E, my divisor and my dividend. My divisor is 5. My dividend is 1, right? Apples to apples. I'm not doing 2. I'm not doing 19. I'm going to do 1 and 1, right? Why do you put the 9 in that column? The reason why is because it helps me track where I'm going to put my quotient. So I put it here so I can track my quotient. Depending on whether I have, if my dividend is higher or dividend is bigger or smaller will depend if I need to skip a column or sit beside it. So it helps me track the quotient. So my divisor is bigger, so I can put it anywhere. I would not recommend it. I would put it here because we're counting it. The reason why is because if you put it anywhere, then you don't know if it's going to be 368 or 38. You know what I mean? So it helps you actually have the place values as well. But you could put it everywhere as long as you know where your place value is, right? So because our divisor is bigger, right? We have our question, 5 times what is equal to 19 or less? We know 5 times 3 is equal to 15. So I add my 3. Okay, I'll see you later, Mr. Clean. I'll see you in my next live. So I have my 3. That's my quotient. Now I need to take away. I need to minus 15. I take away 1 and then I take away 5. Yes, exactly. So then I have 4. I'm only going to compare. I'm not ready to bring it down. I'm only going to compare the 4 or the 5. Who is bigger, 5 or 4? My 5 is bigger. So then I know I'm going to take 2 digits, 45, right? Because 5 times something cannot go into 4. We know we need to bring down the 5. So we need to use 2 digits because the divisor is bigger. Because the divisor is bigger, we have to take 2 digits, 4 and the 5. Now I know how to divide. Yeah, yeah. And you break it up into smaller pieces. You break it up into small pieces, right? We take 45. Why? Because the divisor is bigger. There's a meaning to it, right? There's a reason why we take exactly, Ashley. We cannot take away from 4, so we need to say 5. This is why. So I'm going to say 5. So I'm going in the paper, right? In paper, we bring down the 5. But in abacus, we now know why we have to do 45. 5 times 9 is equal to 45. So I add my 9, right? My answer, my quotient is 9. And then I take away 4 and I take away 5. I take away the 4 and I take away the 5. Yes, that's it. Does that make sense? So and that's the big thing is to be able to understand. It would be a lot harder with larger, but no, it wouldn't be. It'd just be different. It would just be a different procedure. We can do it. Do we have time? We can do one. It it does. I'll have to work. It does. I have to work more on it. Yes, yes. Okay, we'll do one more, and then I do have to go because I gotta go judge some track meet. Yeah, you ready for one more? Okay. Here's a caveat. Because it's 2 digits, we can do 2 digits, right? To do 2 digits, whatever you do one, you'll do the other. And I'm still kind of marinating on how to explain that, just so you know. Let me find. Um, where are we? Okay, hold please. Okay, let's do. If there's remainders, then you just kind of round up. It's a little different when there's 2 digits. Okay, nope, that's not it. I'm trying to. It's always easier when the numbers divide out to itself. Where is my. No? Okay, hold on. Hold, please. Okay, let's try that. Let's see how that works. Okay. Can we do on division more tonight? I will try to do division more. We need good numbers. Yes, we need good numbers. Yes, thank you, Ashley. Thank you for your help. I do appreciate it. It makes sense, right? Yeah, not a problem, not a problem. We'll try to do more division tonight, but it all depends on how fast the class goes. Obviously, the more people, the slower the class. There's 12 of us. So the class goes fast. You know what I mean? But it all depends on how class is. And I don't touch on division very often because I already lose people at adding and subtracting. So, and Ollie was able to pick it up really quick, so that was cool. That was really good. And what we're gonna do, okay, what we're gonna do is this. Let me see if I can. Okay, here is. Let's see how this number goes. We're gonna do 47 divided by 846. Okay. Now it's still the same. We still need to compare, right? We still need to compare our S and our E, our divisor and our dividend. We still need to compare. But this is what it is. Divisor 1 digit and divisor 2. Do you mean divided by? Yes. 846 divided by 47. Yes. So what we're going to do is understand we have divisor 1 digit, and then divisor 2 digit. Okay, we're still going to compare. We compare one, we only compare 1 digit. We compare 8 and we compare 4. Our divisor is 4, our dividend is 8. We still only compare 1 digit. Oh, I'm sorry. Yes, thank you. Thank you. Place value. Yes, you're right. Sorry. 1, 2, 3 is my dividend, and 1, 2 is my divisor. My dividend is 3, take away 2 divisor equals to 1 placement value. So I'm going to go over here because I need to put my dividend on the abacus. 1, remember our dot is over here. So I'm going to see if I can find some tape. Let me get some tape. Because I want my. Oh, I guess that's okay. I guess that's okay. Okay. So our dividend and our divisor. We have our quotient, and I'm going to put my dividend on my abacus. So I do 8, 4, and then 6. Okay, 8, 4, 6. Right. That's my dividend. I'm going to compare. I have to compare. Right. 4 and 8. If I go too fast, let me know. I'm going to try to go slow. Dividend is bigger. So we know we're only going to do 4 times what is equal to 8 or less. Okay. 4 times 2. Thank you, Ollie. Thank you. Yes, thank you, Shoemaker. 8 is bigger. 4 times 2. Take away 8. So I'm going to take away the 8. This is not a good question because we got to do something extra. All right. I'm going to continue. I'm going to continue. Let's see how well we do. 2 times, okay, because 2 times 4 is equal to 8, whatever I do to the 4, I got to do to the 7. Okay? Whatever I do to the 4, I got to do to the 7. So 7 times 2 is equal to 14. I don't have enough. My quotient is too big. So what do? I have to make my quotient less. I understand that makes sense, right? It's too big. There's not enough to take away 14. So what do I have to do? So instead of saying 2, I have to do 1. So instead of saying 4 times 2 is equal to 8, I have to say 4 times 1 is equal to 4. So now I'm backtracking. Does that make sense? My brain is melting. Yeah, this is not a good question. I'm sorry. I apologize in advance. I have to backtrack, right? So instead of saying 2 times 4, I have to say 1 times 4. So what does that mean? I take it 1, right? 4 times 1, 4 times 1 is 4. But remember, if I did 4 times, I got to add back my 4 that I added. So I got to add back my 4. Does that make sense? Yes. So we have to put back our 4 that we took away. Yes. Because the quotient was too big. Yes. The quotient was too big, so we got to take it back. Yes. So now it's 1 times 7. 1 times 7 is equal to 7. 7's a single digit. I go back 1 column and I take away the 7. I go back 1 column, I take away the 7. I laugh because this is more complicated than I thought it was, and I feel sorry for you guys. Minus the 7. Minus 7 is what? Minus 7 is minus the 10 plus the 3. I take away the 10 and I add the 3. To add the 3, what do I do? I'm so lost. Add the 3. Well, what we got to do? We got to minus the 7. To minus the 7, and it's not here. I got to minus 7 here. I got to go back 1 column because 7 is a single digit. Yes, minus 3. Minus the 3 is plus the 3. Plus the 5 minus the 2. All right. Are we done? Oh, sorry. I forgot to skip. That's what it is. Yeah, because the E is bigger, we had to skip a column. So what are we doing now? We have to compare. We're done. So what are we going to do? We have some dividends left. We have some dividend left. We have 4. I got to change color. We have 4 and then we have 3. Hard to say. Yeah. Okay. 4 and 3. Who's bigger? We're comparing again. We're only comparing our dividend and our divisor. Who is bigger, 4 or 3? 4 is bigger. So what are we going to do? We know 4 times cannot go into 3. We need the second one, right? We need the second digit. We need this digit over here, which is 7, right? 7. What times 4 is equal to 37 or less? 4 times 8. I add my 8 as my quotient. I add my 8. I take away 30. I take away 6. Oh, shit. It is not. It's, oh yeah, 9. You're right. You're right. 9, 9, 9, 9. Take away 36. 7 times 6, 7 times 9. Whatever we do to the first one, we got to do the second one. So 7 times 9 is equal to 63. There's not enough to do 63. So guess what? Our quotient is too big. Yes. So we got to go back. Yes, when the divisor is too big, we got to take 1 from the answer. Thank you, Ashla. Yes. So we have to go back to the first digit, take 1 from the answer, right? Because that's what it is. It's a possible quotient. We're doing possibilities. So now we take away 1 here. We have to add the 4 back because we took too much. We have to add the 4 back plus the 5 minus the 1. It is 8 after all. It is common multiple. I mean, no, not common multiple. We're not doing common multiples. So what do we do? 7 times 8 is equal to 56. So we take away the 50 and we take away the 6. I'm lost. Keep going. I'll catch up tonight. Okay. This one is it's trickier because because of the 2 digits. I got to get a better question. I have better questions. This one's not a good one. Why? Because the quotient gets too big. When the quotient gets big, we got to remove it we got to go down 1 notch. Yeah. So what we do is we try our luck with the first one and then we do it again with the second one. If the second one can't do it, then we got to go back 1 step. That's why it's good to know what. Yeah. I understand the process. Yes, you do understand the process and that's amazing. Because instead of saying how many times does 47 go into 484, right? Instead of saying this, We break it up into smaller chunks. And that's why I think it's the greatest thing next to sliced bread, right? The only thing is you need to understand the process. Once you understand the process, then you can break it down and it doesn't matter how big the number is. You don't need to say, okay, well, what? 47 times 2 is equal to 80, 94, right? We don't need to say this. We don't need to say it. We don't need to chunk it this way. What we do is we chunk it one at a time. That's what we're trying to do. 347, 300. Does that make sense? So when we're doing it, we're trying to chunk it into smaller chunks. Divided by 47. Okay. Yeah, we could do that. Let's do that. I think it'd still be the problem. Let's see. Okay, I'm going to do a new page. Right? So 47 divided by 376. So again, it's the same thing. 1, 2, 3, 1, 2. We're here. I had 3, 7, 6. Three, 7, 6. Right? Yeah, that's why I try to do like all the labels and stuff because there's a lot of words going flying around. So the first thing we're going to do is this 3 and this 4, right? This is the second half of the problems. We can try this. So who's bigger, 4 or 3? 4 is bigger. So we know what? We know 4 times what is equal to 33. Is it 3? No. 4 is bigger. 4 cannot go into 4 cannot times into 3, right? Yeah. So what are we going to do? We got to take the second digit. We got to take the second digit right here, right? Into 37. So we got to do 37, right? Yes. So it makes sense. So now 4 times 9 is equal to 36. So we put the 9 here. We take away 30. We take away 6. Now the problem is what? We have 16 left. 7 times 9 is 63. 63. We cannot do it. We got to go back a number. Cuz why? 47 times that by 9 is what? 47 times that by 9. Let me write it in a different one. 47 times that by 9 is equal to 423. Yes, Ashloy. So what we need to do is this is too big, right? We need to take this out and we need to make it smaller. We need to take 1 from the answer, take 1 from the answer. So now we're rewriting this, right? So instead of saying 36, we want to say 4 times 8 is equal to 32. But all we got to do is just add back, right? This one changes to 7 times 8 is equal to 56. So we take 1 from the answer, add the 4 is back to here. Now we're at 56. 56. Now this works out. 7 times 8 is 56. 7 times 8 is take away 50, take away 6. So my final answer is 8. Yep. Yep. So the answer is 8. Yep. Yeah. So it's going too much, right? I'm getting it. Yeah. But see, the thing is what we do is we break up the individuals. We break up the individual. We break it up into smaller pieces. Even the backtracking. Yep. Backtracking. Because that's what it is. What we need to do is, yeah, make sense? You understand this process, it becomes scalable. It doesn't matter how big the number gets, you just do it again. Thank you for the teacher. I am going to head. Okay, yeah, thank you, Ouija. I will see you in my next live. I got to head out too. I got to head out too. This is too exciting. It's exciting because it gets to a point where like I can talk about things. So the whole answer was 18? Ooh. Yeah, the whole answer was 18. Yes, the whole answer was 18. Yes. Yeah. Yeah, it's not very often do I get to explain division, but I do enjoy division because the process is fun. That was a good one. Yeah, thank you, Ouija. You have a good one too. I will see you in my next live. I hope that was okay. I hope that made sense. But yeah, later on I will be going into making out my books, but I haven't gotten there yet because it takes a little bit. Thank you, Comfy Bear. Yeah, of course. Thank you guys. Thank you guys for being patient. Even though this was a very hairy question. That's how we did long division. Yes, it is how we do long division, but we don't do the big numbers, right? What we do is we break it up into smaller chunks. Yeah, thank you, Kat. No, thank you, Kat, for joining. I do appreciate it. I hope that helps. I hope that makes sense. But this one was a little hairier. It was only because the possible quotient, exactly what Ashley said, the possible quotient was too big, so you have to take one step back. All right, thank you guys. This is better than Fortnite because you're getting wrinkles in your brain. You're getting wrinkles in your brain. But no, I appreciate it. Thank you guys for joining. Thank you guys for being patient and understanding. It is a process. It is a process. But once you get it, it goes in it. That's all it is. And that's what it is. Abacus that's what makes abacus super easy. It's the process to understand it. See you tonight. See you tonight. Hopefully I'll have enough energy after the judging. But yes. Is this Lynette from Ginseng? No, I don't know what ginseng is. Genshin. I don't know what that is, Braden. So thank you, Ali. Thank you for your patience. Thank you for continuing on to understanding how to do division. Thank you, guys. Thank you. Thank you. Have a good day. Have a good day. And I will see you in my next live. See you in my next live. Thank you, guys. Bye. Oh, I gotta end it.